Hello, good morning. So let's get started. We are going to be doing lecture 11 today. It's relatively short compared to, some of the other ones that we've done. Certainly much shorter than, the kidneys and the skeletal system. We probably should be able to finish it in one lesson. So um, here we go. Let's start with the anatomy of the female reproductive system. And we're going to go ahead and pull up the study guide. And we're going to find the diagram to label right here. So I'm just give you a moment to bring that up and then we'll do it together. My camera is not working this morning, but that's okay. You don't really have to see me. So please get to the study guide and we're gonna do it. So this is a mid-sagittal view of the reproductive system, and there are some parts that you might recognize from previous unit. For example, from the skeletal system, you know that this is the symphysis pubis. Okay, that's the part that connects the pubis in the pelvic area, right? So, what do we have here? Well, let's start with this over there. This is the ovary. That's the ovary, and that's where meiosis takes place. Okay, that's where all the eggs are going to be stored, and that's where gamete production occurs, basically. Now, connected to the ovary, we have this little structure right there. I know they don't have a line pointing to it, but we can add our own. This is the fimbriae. The fimbriae, okay, which are there to help guide. They're kind of like hair-like structures, I suppose, guide the egg into the fallopian tube. Guide the egg into the fallopian tube. And there is the fallopian tube right there. Which is the site of fertilization. Okay, that's where the sperm is going to fertilize the egg. Now, there are a couple other things here. We have anybody know what that is? This whole thing?
You there?
The what? I'm sorry?
It's you there?
The uterus, yeah, the uterus.
Yeah, uterus.
Yeah, yeah. So that is the uterus, and that is where the baby grows. Okay, the womb, basically. Now, the uterus has a very strong muscle, a very strong muscle layer. We call that the myometrium. the myometrium, which is the uterus muscle. That's the muscle that pushes the baby out during labor. This part of the uterus is called the fundus. Okay, it's kind of like the deepest portion of the uterus. And then the opening. Anybody know the opening to the uterus? What do we call that? Starts with a C. Some of you might know it.
Cervix.
Cervical canal.
Yeah, that's a cervix. Very good. Cervix. Okay. So when the baby is growing, there is actually a mucus plug that forms that seals the cervix. So nothing goes in, nothing goes out. Okay. A pap smear, you might have heard of that, it's a screening tool for cervical cancer. Yeah. So that's the fundus is like the deepest part, and then the cervix is like the entry, if you would. And then the myometrium is the muscle. Now there is also a lining right here, and that is where the blood vessels are going to be developing in preparation for pregnancy. So that lining is called the endometrium. It is the lining of the uterus. And the thickness is regulated by estrogen and progesterone, okay, which we'll talk about later. Okay. When the baby is growing inside the uterus, obviously it can get heavy. And so we don't want the uterus to kind of fall down and descend. So what we're gonna do is there's actually a ligament that help hold it in place. And that's this ligament right there. Okay, that is called the round ligament. Okay, it holds the uterus in place. Okay, what else do we have? There's a ureter. We can just color it. It's already labeled for us. That's ureter. Of course, that connects to the urinary bladder, right? Down here. And you know, continue going up, that would take you to the kidney, of course. How about right here? This one, again, there's no label to it. Let me just try to highlight it for you. Right there. What would that be? We learned that already before. What is that? You guys just did your kidney quiz 2 days ago. You should know what that is.
Urethra.
Mm-hmm. Very good. That is a urethra. I mean, look, it's connected to the urinary bladder, right? And then over here, K, that's the vagina. And this is the, well, let's do it a little bit higher. That's the rectum. Okay. And that's the anus. So there you have it. The major structures that we have to know for the female reproductive system. Nothing too complicated. Any questions? Okay, we'll do the men later. Let's just finish talking about female first. So there is all the same stuff. You can compare what we have. I mean, there are a few extra labels here, but just know the ones that we did on the diagram on the study guide, and you should be okay. All right, so let's take a closer look at the ovary. Like many other organs that we talked about, the ovary is made up of the outer cortex as well as an inner medulla. Okay, so in the cortex, there are many follicles, each containing an immature ovum called the oocyte. You might remember this from last semester. The oocyte is going to undergo gametogenesis. Okay, it's going to undergo meiosis basically. First division, second division, and then you're going to end up getting the polar bodies, and then you were going to get one egg, right? That's like really big. And the female is born with as many as 2 million follicles, but the number is reduced to about 300,000 to 400,000 by the time of puberty. And these follicles are, again, what's going to eventually become the egg, right? Remember, the meiosis process starts as early as when the female is still in the mother's body, right? And then the meiosis gets suspended in prophase 1, and you know this suspended stage, that's what the follicle is, and then it will continue on to develop once puberty hits, but only one follicle, typically only one follicle will develop per cycle. So only a small number of follicles, about 400, ever become completely mature, because as we all know, it's just one egg per cycle. I know it says per month here, but then the length of the cycle varies from person to person, right? Textbook usually say 28 days, but you know it could be longer, could be shorter. So you know typically we say one egg per month, but really it's per cycle. And since all the oocytes are present at birth, they age as the woman ages as well. And so, and you can see in this graph, the incidence of trisomy, and this is something we talked about last semester. Trisomy is when the chromosomes fails to separate during meiosis. We call that non-disjunction, right? You might remember that. Then it causes the egg to have an extra chromosome. If that egg gets fertilized by a sperm, then the offspring is going to have an extra chromosome, leading to trisomy. And the incidence of trisomy increases exponentially with a woman's age. Okay, so that's why some people, I mean, celebrities mostly, right? If they could afford it, they freeze their eggs early on, and then they can have a kid later on in life. So the egg is released by the ovary. We mentioned that already, and it's drawn by motions of cilia into the fallopian tube. And the fallopian tube connects the ovaries to the uterus. And along the way in the fallopian tube, the egg is guided by cilia. Again, that's also something we learned in the previous semester when we learned cellular structure. When a woman becomes pregnant, the embryo attaches to the endometrium, the uterine lining, which then it's going to cause the placenta to start to develop, and then the baby continues to grow inside the uterus, right? Again, this nothing too complicated. I am pretty sure a majority of you already know these things. So this is just talking about the the function of each of these things. Nothing too complicated. Again, I'm not gonna read through them. It's basically what I already told you as we were labeling. Feel free to read through it yourself. What is this? Yeah. So what I really want to spend time explaining is this hormonal regulation of the menstrual cycle. Like that's like the difficult things that most people don't know about, and it requires some explanation. So please take out a piece of paper, and we're gonna do another class note. Okay. Now, what I'm about to tell you is useful information that we will continue to refer to in the next lecture. Okay, we're nearing the end, right? Just one more lecture after this. And this, before I talk about the hormonal regulation for the menstrual cycle, I have to teach you about the relationship between the hypothalamus and the pituitary gland. Okay. Hypothalamus and the pituitary gland. So let's draw them out. Okay, this is the hypothalamus. And then under the hypothalamus, there's that's where you will find the pituitary gland. Okay. So the pituitary gland has a bigger one. That's called the anterior pituitary. It's like drawing a baby's butt, okay? The bigger cheek, that's the anterior pituitary. And then the smaller one is the posterior pituitary. Okay? Now don't memorize the left is always anterior or the right is always posterior, okay? Like it depends which way your head is looking at, right? So in this case, the head is looking to the left side of the picture. So that's where the anterior pituitary gland is. This here, the little stalk that connects the hypothalamus and the pituitary gland, that's called the infundibulum. In, and then fun, dibulum. Okay, it's a stalk connecting the hypothalamus to the pituitary. Okay, any questions so far? All right. So the hypothalamus has two kinds of neurons. There are two kinds of neurons. There are neurons that, let me choose a nice color here. There are neurons that have the cell body in the hypothalamus. And then the axon is very long. It goes all the way to the posterior pituitary gland. So that's like a physical connection. It's really long. Okay, so these neurons the cell body is in the hypothalamus, and the axon extends into, I'm just going to put PP, okay? Posterior pituitary gland. So 2 hormones are made in the hypothalamus by these neurons and are stored and released from the PP. So the hormones that I'm talking about is ADH, which you already learned. And then there's another one called oxytocin. Anybody heard of oxytocin? Maybe if you have a child, you might have heard of oxytocin. Anybody? Oxytocin? Okay, now that's the one that induces labor. Sometimes they, if you're not going to labor and you're late in the pregnancy, they might give you like a synthetic oxytocin to start your contraction. Okay, so more on that next week. But ADH and oxytocin, these are hormones that are made in the hypothalamus. They are packaged into vesicle, which then goes down the axon, and then it's stored and released from the posterior pituitary gland. Okay. Let's skip to the anterior pituitary gland for a moment. The anterior pituitary gland makes its own hormone. Right? It makes several, I would say makes its own hormone. Okay? And there are many. The ones that we are interested in for this lecture are called FSH and LH. Okay? The ones related to reproductive system are FSH and LH. I will tell you what they stand for later on. Okay, I'll tell you now, but we'll write down later. Okay, follicle stimulating hormone, and then luteinizing hormone. The release of anterior pituitary hormones are regulated by the hypothalamus. Okay, I'm just letting you catch up first. Any questions so far, by the way? Do you know what we're drawing here? Okay. Gonna go back up here. So there are another group of neurons. Okay, so these neurons, they don't go all the way. And their axon kind of stop at the infibulum. Okay. So these neurons secrete two types of hormones to regulate the anterior pituitary gland. And the hormones are separated into two categories. Okay? They're what we call releasing hormones and inhibiting hormone. Sort of like green light, red light. The releasing hormone will allow the anterior pituitary gland to release hormone. The inhibiting hormones will inhibit the pituitary gland from, releasing hormone. Okay. So there are many different kinds of releasing hormone and inhibiting hormone. The ones we are talking about right now is called GnRH. Okay, you know it's a releasing hormone because it ends in RH. This is a very long name, okay? Gonadotropin releasing hormone. We'll write down later. So the GnRH is like a green light, and then it will go and tell the pituitary gland to, hey, you have the go ahead, you have the permission to release LH and FSH. Okay. So that's the relationship between the hypothalamus and the pituitary gland. Okay, do we have any questions before I tell you more? Really? Everybody understand this? Okay, that's good. Okay, let's talk about the ovaries a little bit. All right. So just to quickly recap, that's one ovary. That's another ovary. Okay. And you have the fimbriae and the fallopian tube. Okay, and that is going to be the uterus, right? With the muscle. Fundus and then cervix, right? So again, the egg is going to be here. And then, if there is sperm, that's where fertilization takes place. If the sperm goes the other way, then, no fertilization. How long do you think the sperm can stay in the female body? Anybody? What's the
A few
window?
days?
Yeah, a few days. Like how many is a few? Like, 5 days, 6 days, 2 days, 3 days? What's
I think it's
3
like
days.
4 or 5.
yeah. Four is being optimistic. Yeah, around 3 to 4 days. Okay, let's take a closer look at the ovary. Closer look at the ovary. There we go. Oops. Let's try it one more time. Okay. So that is, you know, the fallopian tube, huh? So there is the follicle, which again is gonna mature into an egg. It's gonna mature into an egg. So as the follicle develops, right, it is going to be releasing a hormone. And that hormone is estrogen. Okay. I don't know why I wrote it 3 times. But as the follicle develops, it's going to be releasing estrogen. And this phase, right, where the oh, can I do that nicer? This phase where the follicle is developing, well, it's called the follicular phase. Follicular phase. Okay. So the follicle develops and estrogen is released. Now, if we think about like a 28-day cycle, the follicular phase is day 1 to 14. Again, it could be longer or shorter, depending on the person. Once the egg is developed, it's going to get released. So this is what we call ovulation. Ovulation. Now, after ovulation, like the leftover stuff from the follicle, right? There's some stuff left over. Okay, like the egg is released into the fallopian tube, but then there's some leftover tissue. That stuff is called a corpus. Corpus just means like a bundle, right? Like a group. Corpus luteum. Okay. Corpus luteum. These are leftover tissue from follicle after ovulation, after the egg has been released, right? Now this corpus luteum is gonna grow a little bit, okay? It's gonna grow, and then, you know, if there's no pregnancy, then it's gonna break down. So it grows, and then it breaks down. Right, so this part here, that is called the luteal phase. Luteal phase. Which is the corpus luteum develops, and if there are no pregnancy, it breaks down. So this would be like 14 to 28. The follicular phase can be longer, okay? But based on my understanding, the luteal phase is always going to be 14 days before the menses. Okay, so like your first day of your period, count 14 days back. That's when the ovulation had occurred. Now, as the corpus luteum is developing, it's gonna pump out another hormone. Okay, I'm just gonna write once this time. That's the progesterone. So are we okay? I'm gonna connect everything for you now. But I just want to make sure that you understand everything I've said so far. Okay, let's go back. I mean, don't go back, you stay there. But I'm just gonna borrow this picture. I mean, you can go back to do it in the study guide. But I'm just gonna borrow the picture here. Okay, so here we go. This is the hypothalamus. That's the infundibulum, and that's the anterior pituitary gland. And you can see that there's like blood vessels, capillaries, right? That allows the GnRH to be distributed very quickly. Okay. So let's take a look at what happens here. There's like 1, 2, 3, 4, 5. So I'm gonna try my best to write it out for you. Pen is not working. Give me a second. There we go. Okay, number 1. What happens in number 1? So at the beginning, the hypothalamus. Hypothalamus secretes GnRH, which is a green light, right? Releasing hormone. Green light for the AP to release hormone. Secretes GnRH, which stimulates the anterior pituitary gland to release FSH and LH. Okay. Now, both of them are being released, but this is the dominant one in this round. Okay, it's mostly FSH. Okay, so I'll put FSH and LH. Okay. I know in this diagram it only says FSH, but really it's like both at the same time, but more so for the FSH. Okay, so what is FSH again? FSH is the follicle stimulating hormone. Knowing what they stand for will help you memorize what they do. This one is luteinizing hormone. Okay, so because we're in the first half of the cycle, the follicular phase, that's why FSH is the stimulating. It's the dominant one. Okay, as the name implies, it's a hormone that stimulates the follicle. So FSH travels through the blood to the ovary. And stimulate the follicle to develop. Okay. Now, I already told you, as the follicle grows, what hormone is released? What hormone does the ovary release?
Estrogen.
Yes, releases
Yes.
estrogen, yes. And estrogen has two effects. Number one, positive feedback on hypothalamus and AP to release more GnRH, FSH, and LH. Okay. A positive feedback is a situation where the end result exaggerates the trigger. Okay. So in this case, we started with increased GnRH, which leads to increase in FSH and LH, which then basically increases estrogen. That's the story so far, right? So in a positive feedback, what happens is this goes back and then it tells them to, hey, let's make even more. As opposed to negative feedback would shut it down, right? Your thermostat, it's an example of negative feedback. Okay. When the temperature rises, it will turn off the heat. Okay. When the temperature drops, it will turn off the AC. So that's the first effect of estrogen. The second effect is it will thicken the endometrium. The endometrium. Right? By stimulating growth of blood vessel. Right? This is to prepare for pregnancy. Okay, because the egg is going to be released soon. And so we want to get the endometrium, the lining of the uterus, ready for the baby. Okay, so that's like number three. It's going to go back to the hypothalamus. What it doesn't show in this picture is, it's going to go to the endometrium as well. Did I miss a number? Oh, number 4 right here. Yeah. So number 4. Okay, so now that the estrogen goes back to the hypothalamus and the AP, what happens is the positive feedback, estrogen increases GnRH secretion from hypothalamus which results in more FSH and LH to be released from AP. In fact, the second time around, there is a sharp rise in LH. We call this the LH surge, which trigger ovulation. Okay? A sudden increase in the LH is going to trigger ovulation. The LH is actually that's the hormone that's that you're testing for in an ovulation kit. Ovulation kits detect the level of LH in urine. So how ovulation kit works is basically you have to pee on the device when you suspect ovulation is coming. So and then it's like an antibody test. Yeah, so it would detect the level of LH in your urine sample, and then you do it on the next day, and then on the next day. So it compares it with the previous days, and then if there's a sudden rise, drastic increase, then you know, like today is the ovulation or tomorrow. So that's useful information, right, for pregnancy planning. Are we okay? All right, I'm just gonna go back and grab the other picture. Here. So number six. Number 6. Number 6. Okay. Following or after ovulation, the follicle develops into what do we call the thing? Can you guys like go back and check your notes? Like the leftover tissue. What do we call the?
The
Corpus
corpus luteum.
luteum.
That's right. Develops into the corpus luteum. And progesterone. Progesterone is released from ovary. Okay. And then what happens? There are 2 effects of progesterone. Number 1, you can see there's a negative feedback this time. We will inhibit hypothalamus, which will decrease GnRH, and AP, which will decrease FSH and LH through negative feedback. Okay, it makes sense to not have FSH and LH anymore. The egg is already in the fallopian tube. We don't need another egg. Okay. Number 2, since the egg is already in the fallopian tube, there's a high chance for pregnancy, right? So the progesterone will further thicken the endometrium. In preparation for potential pregnancy? Okay, so that's that's basically number 6 and number 7. 6 and 7, right? Release 7, I guess. Okay, so finally, if pregnancy does not occur, as is the case most of the time, right? Uh, and then what happens is the corpus luteum breaks down. So help me out here. If the corpus luteum breaks down, what hormone level is gonna drop?
Progesterone?
That's right. So then we would have decreased progesterone because progesterone is produced by the corpus luteum, right? Now, without progesterone, there are no more hormones sustaining the endometrium. So drop in progesterone will lead to the shedding of blood vessels in endometrium. And that is going to lead to the menses. Menses, which is like marks the beginning of the next cycle, right? More importantly, the progesterone was suppressing the GnRH and the FSH and the LH. So if you take away the progesterone, then the suppression is gone. Right? So negative feedback is lifted, and then you have increase in GnRH again, and the next cycle begins. So that's basically what happens. No questions for me? Are you guys sure?
I have a question.
Yeah, please.
Seriously. When there's this cycle stop and don't repeat again, and why?
Why does the cycle repeat again?
Yeah.
Oh, because the egg is gone now. So we need another egg, right? We need to get another egg out of the ovary so that, there's another chance for pregnancy, right? There's another chance to have the egg in the system again. And then, because, the body needs a way to ensure the continuation of the species, right? Continuation of making sure that we're able to make more humans, basically. So the egg is gone. If there's no pregnancy occurring, the egg will just continue go onward to the uterus, and then it's going to be released from the body, and then now we need to get another egg, basically, right?
Okay. Thanks.
Okay, there must be another question, right? Because usually, no, I tell you what happens now, right? If no pregnancy occurs, then usually people would ask, then what happens if there's pregnancy? Okay, so if pregnancy occurs, right, then the egg is gonna fuse with the sperm to form the zygote. The zygote, okay, zygote. It's gonna develop. Right? One cells become two, two becomes four, four becomes eight, and eventually it becomes the embryo. which then implants into the endometrium, and then the developing placenta secretes another hormone called HCG. It's in the PowerPoint. Okay? It's called the human chorionic gonadotropin. Very long name. Okay? We're just gonna look at it from the PowerPoint later. Secretes HCG, which sustain the corpus luteum. Why? Why do we want to keep the corpus luteum?
For the baby?
For the baby, that's right. The baby's already growing in the uterus. Okay, we don't want the corpus luteum to shed. Sorry, we don't want the corpus luteum to break down, because if corpus luteum breaks down, progesterone is going to go down, and then the uterine lining, the endometrium, is going to shed, and then that's going to cause the baby to be lost as well, right? So the HCG sustains the corpus luteum, and therefore maintain progesterone level. Okay. Once the placenta is fully formed, it will be the main source of estrogen and progesterone. Okay. That's it. So HCG is for pregnancy kit. Okay. That's, yeah, sorry, go ahead.
When they say a female miscarries, is that when the corpus luteum breaks down?
That's one of the possibilities, yeah. But there are other complications as well, right? Sometimes they could implant in the wrong place. It's called like an ectopic pregnancy, and that just not able to sustain the baby because the tissue is not meant to, support the baby in those locations, right? That could lead to natural miscarriage as well. But there's a lot of reasons. Okay, so pregnancy kit test for the HCG. If there's high level of HCG, then the person is pregnant. I read something a while back, like there's a man, he was like peeing on his girlfriend's pregnancy stick for fun, and it was positive. Okay, so it turns out men should not have the HCG. Okay, and if they do have the HCG, it's sometimes an indication of cancer. Okay, and in the prostate. So he found out. You can look it up on the internet if you are interested. So that's that. Let's go back to our what else do we have here? Let's go to this graph here. Okay, there's a graph right there. Second page of your study guide. Let's go through it together. So the first line here, that would be the this is the FSH, okay? This one is the, sorry, no, this is the LH, the luteinizing hormone. This is the FSH. Estrogen here and progesterone here. So let's see what happens. 28 days, first 14 days. What do we call the first 14 days? Come on, you remember.
Fallopian.
Follicle phase.
That's right, follicular phase. Right, so you can see the follicle is growing, growing, growing. And I know I have been repeating this several times already, but when the follicle develops, what hormone is released?
Estrogen.
Estrogen. So I want you to look at the estrogen curve. Look, it's going up, isn't it? It's going up, 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 up. And then it's, like the highest right before ovulation. Why? Well, over here, the rise in estrogen is going to create a positive feedback that results in the LH surge. Okay. LH surge caused by increase in estrogen. Okay. But as soon as the LH surge occurs, as soon as the ovulation happens, then estrogen drops a little bit because the follicle is no longer there, right? The follicle is no longer there. We're done with the follicular phase, so that's why the estrogen drops a little bit, right? And then over here, the next 14 days, we have the luteal phase, which is dominated by the corpus luteum. And you should know the corpus luteum releases progesterone. Right? And that's why there's no progesterone at the beginning, but then it goes up, it peaks. Okay, peaks over here, increase in progesterone. Now, what's the relationship between progesterone and FSH and LH? If progesterone goes up, what's going to happen to the FSH and LH?
It's gonna come down.
It's going to come down. That's right, because increase in P equals to decrease in LH and decrease in FSH. You already have an egg in the fallopian tube. We don't need another one. This is negative feedback. Okay, whereas over here, increase estrogen equals to increase in FSH and LH. This is called positive feedback. Okay. And I want you to take a look at the endometrium here. Okay, this is the menstrual flow at the beginning, but then as estrogen increase, the endometrium gets thicker, thicker, thicker. And then over here, after the ovulation, the progesterone is going to take over. But then you have this rapid shedding. Okay, like sudden decrease. That's because the progesterone was gone, right? So that's that. That is all for the female reproductive system. Okay, why don't we take an early break? We'll come back at 9:40 and then we'll do more. Okay, see you in a bit. So let's go back to PowerPoint for a second here. This is just another picture over here. And oh, sorry, just give me a second. Okay, so this is just another picture that shows the same information. And you can see the graph is like sometimes not exactly the same in terms of where they overlap and stuff, and it doesn't really matter. The key information is still there. You still see the same peak in the estrogen and the progesterone over here. And it's good to study this on your own and make sure that you fully understand it. Okay, this is the HCG I was talking about, which stands for the human chorionic gonadotropin, and the HCG help maintains the corpus luteum until the placenta is fully formed, so that it can produce its own progesterone and estrogen. So, couple of questions here. Let's take a look. Fertilizations occur in the where?
Fallopian tube.
In the fallopian tube, that's right. Next one here.
Estrogen. Progesterone.
That's right, estrogen and progesterone. Very good. Okay. And then one more here.
Decrease FSH and
E and D.
increase LH.
Okay, yeah. So if you have high progesterone, you will decrease FSH, you will also decrease LH. And you actually will also decrease GnRH, but that's not an option. So that's all we have. Okay, how about this one?
HCG.
Yeah, that's right.
LH.
The oh, actually, yeah, ovulation kit. Ovulation kit is LH. Right? Pregnancy kit is HCG. Okay. All right, so that's it. Let's go over the men. The men is much easier than the female. In terms of the things that you have to learn. Okay, so let's go to the men's diagram, which is right here. Okay, this is the front view. All right, here we go. This is the front view. Anterior view. Okay. Lots of tubes here. I guess we'll start at the bottom. What do you think those are? Those are the testes, right? Testes for plural. Testis, T-I-S for singular. And then, I mean, that's where the sperm are produced, right? And then there are these things on top of the testis. Those are called the epididymis. Epididymis. This is where the sperm have swimming lessons. Okay, so sperm matures and become mobile. They learn how to swim. And then they're temporarily stored there until released. All right, over here we have this tube here. Very long tube. Anybody know what those tubes are called?
Ureters.
good try. Ureters are actually up here in H. Why don't we label those first? Ureters.
Difference?
Yes, right. These are the vas deferens. Vas deferens. Vas deferens. Okay. Carries the sperm to the next part of the reproductive tract. And you know, people can have a vasectomy, basically cut them off, and that will cause the sperm, cause the semen to not have any sperm, and that's an option for men who do not want to have kids. So that's the vas deferens. This circle thing right here, that is the urinary bladder. Urinary bladder. Right there. Okay. What about this little ball thing underneath the urinary bladder?
Prostate gland.
That is the prostate gland. Very good. Okay, prostate gland. I'll tell you what it does in a bit. There is the urethra here. Okay, I'm just going to color the urethra for you. It actually goes through the prostate gland. Okay, like a straw through an orange. You can think of it like that. Okay, there are two little smaller ball things here. Those are called the bulbal urethral gland, also known as the Cowper's gland. We're just labeling now. Okay, I'm not telling you what they do in a bit. Not yet. I'll tell you what they do in a bit. J is the seminal vesicle. Seminal vesicle. There we go. So the seminal vesicle, the prostate gland, and the bulbal urethral gland, they contribute to semen volume. Okay. So semen contains the sperm, but there are like other stuff in it too. Okay? There are like nutrients. There are like some alkaline solution. Alkaline is opposite of acid, right? Because the vagina is acidic, it will kill the sperm. So you need to have some base in the semen to neutralize the acidity, right? To keep the sperm alive, right? So all those things are going to be added to the semen by these glands. Okay, and then there is it's just another duct right here. That is the ejaculatory duct. So that's smooth muscles, and their contraction will lead to the ejaculation. So there you go. All right, moving on. This is the sagittal view, mid-sagittal view. So we have this thing again. That's the symphysis pubis. What is this? What's A?
Urinary bladder.
That is a urinary bladder, yes. Maybe we can color it. And over here, that is the prostate gland. Okay, just compare to the higher picture. What do you think this is? So that's the prostate gland, and on top, right? Those are the seminal vesicle. Seminal vesicle. How about a little guy here?
The Cowper's gland.
Yeah, the
Yeah,
Cowper's gland.
Bolosio. Yeah.
That's right. I like the long name more. Bulbo,
Yeah,
urethra. But Cowper's gland is correct. Okay, so this gland actually makes the secretion like during intercourse, makes the secretion before the actual semen comes out. So there are two purposes. First purpose is the secretion will flush the urethra, because like urethra is also where the urine comes out, right? So the secretion will flush the urethra, make sure that the urine is kind of cleansed out. It's not going to kill the sperm or interfere with the sperm's mobility. And the second function is to lubricate the penis for the intercourse. So that's the bulbourethral gland right there. Okay, other things in this diagram. Over here again, that is the testis. The testes for plural. The skin that wraps around the testes, that's the scrotum. Right? So the scrotum is important to help control the temperature of the testes. If it's too hot or too cold, it's gonna affect the sperm production. So if it's hot, the scrotum pulls the testicles away from the body. When it's cold, it pulls it closer to the body. Okay, we have this thing right here. I mean, it has different names for each of the parts. Okay, I'm just gonna cross them out, and we're just gonna call it the epididymis. Epididymis. I always have trouble remembering where the Y and the I goes. Okay, it's all I except except for this one. Epididymis. Okay. What else do we have? We have K. K is the urethra. A couple other things here. This is the prepuce, which is basically like the foreskin. Like some men have circumcision, right? That's like removing the foreskin here. The head of the penis also has a name, is called the glans penis. C is pointing at this part. And then D is pointing at this part. Okay. So C is called the corpus cavernosum. Cavernosum. And then the other one is called the corpus spongiosum. Basically, they are tissue that has blood vessels in it, and that's responsible for the erection. That's all. Any question?
What are the scale things on the outside?
These things? Oh, I think
Yeah.
those are just the pubic hair.
Oh, okay.
It's a very detailed picture. Okay.
Sorry, another question.
Mm-hmm.
Are we not going to label like the rectum and the anus in this diagram?
We could, yeah. There is the rectum.
Oh,
Yeah. And then there's the anus. Okay. So like for men over 40, right? They recommend checking the prostate, and they actually have to go through the anus and put the finger into the rectum to feel the prostate, because you can see it's really close, right? Like to feel if the size of the prostate is normal. Okay, so that is that. Okay, just go back to the slides here for a second. All right, the testes contains tightly coiled things called the seminiferous tubules. And inside the tubules is where they will undergo spermatogenesis. There are the interstitial cells, germ cells, and Sertoli cells. It's really hard to visualize it. I'll explain. I'll draw a diagram for you and try to explain it for you. The best way to think about it is like instant noodle, okay, ramen. Right? It's like that. Like inside the testicles, they are all packed. Even the drawing resembles the instant noodle, like that. Okay, and so let me try to draw this out for you, and hopefully, hopefully it'll make sense to you once we draw it out. Okay. So, oops. Where is it again? There we go. Okay, so there is the testicle. And inside it's separated into different lobes, okay? Different lobes. I'm just gonna draw a few here. And like I said, it's all twisted up like the instant noodle. Okay, like that. Okay, I'm gonna pull one of them out. Like so many of these diagrams in the whole course, right? Like last class we were pulling out muscles, and today we're pulling out this thing. So this thing is like, looping on its own. It doesn't get tangled, but it's like all over the place like that, so on and so forth, right? Okay, so I'm gonna cut open one of them and take a look at the inside. Do you understand what I'm drawing? Like that. Okay, so this tube here, that is called the seminiferous tubule. seminiferous tubules. I want to draw it a little bit bigger because I need more space. There we go. There we go. Like this is the inside, right? This is the inside of the tubule, right? So on the edge here, this is where you will find the germ cells. Germ cell. And then as the germ cell undergo meiosis, they move towards the lumen, the inside. Okay, and then like you will see these are like the tails of the sperm. If you were in my in-person class last semester, I showed some of you these slides, right? We have like bunny testicles, and then you can see the sperm tail in the middle. So what happens is when the sperm is fully mature, the sperm will break off, and then it will travel through the tube, okay, all the way to the epididymis. The epididymis is up here, right? Remember? There we go. That's the epididymis. Epididymis. Okay, so that's a germ cell. And you will also have other cells right here. Okay. Those are called the Sertoli cells. Okay. And their job, it's in the PowerPoint, right? I'm just trying to show you where they are to help you visualize it. It helps nourish, support the germ cells, basically. Now, in addition, you also have more cells in between. Like they're not in the seminiferous tubules, but they're like between them. Okay, and these are called interstitial cells. Or like I think it's better, the other name is better because it tells you what they do. These are testosterone secreting cells. And testosterone, of course, is like the male one. Any questions? Okay, well, there you go. Now you will never think of instant noodle the same. This is the actual picture, right? Like that's like one of the tubes that I was trying to show you. Right? That's like, you know, like if you take a look at the tube, right? Yeah. Do you guys understand my drawing? Sometimes I wonder, like, I wonder if my drawings are good enough to convey the information I want to tell you. Right? So like that's the inside, and all these lines you see, those are the sperm tail. Okay. All right, that's it. Oh yeah, I saw this news clip. It was kind of funny. The Iowa jury awards more than 1 million to a man who thought he was getting a circumcision but got a vasectomy instead. Because he went in and he thought he was getting a circumcision, but then ends up they cutting cutting his vas deferens. So in the end he becomes sterile, right? I mean, you can reconnect them actually, okay? But then, you know, he sued the doctor, sued the hospital, I think, and then they got 1 million. I remember when I was reading this, I was on bed in the bed, and my wife was sitting beside me, and we're just reading our own thing. And then and I saw this, and I laughed, and I showed her the title, and I was like, you know what? For $1 million, they could cut my vas deferens, no problem. In fact, cut both of them, right? That's a lot of money for something that's actually reversible, right? Like I said. But there you have it. So next, the seminal vesicle. Let's just talk a little bit more about what they do. The seminal vesicle, they are lateral to each of the vas deferens, and it's on the back of the urinary bladder. You can see it over here, right? At the back of the urinary bladder, right there. Okay, and also the back of the prostate, in fact. And it makes up 60% of the semen volume. Right? The secretion is basic, right? And it has fructose. The fructose supplies the energy for the sperm to swim. It's very energy demanding to swim upstream, right? Like against gravity, and it's a long journey to the egg, like you said, right? Like 3 to 4 days on its own, trying to find the egg. So it needs the fructose. There's the prostate again over here. It's underneath the urinary bladder. It's not too big, size of a walnut, and it actually encircles the urethra. Best way to think about it is, again, like think of an orange, and then you stick a straw from one end to the other. It goes right through it. It secretes fluid that is thin, milky color, and alkaline. So again, you see the basic solution, right? It adds to the seminal vesicle. And this solution helps enhance the motility of the sperm. Bulbourethral gland, the little two things, the Cowper's gland, very small, size of a pea. They are at the base of the prostate gland, close to the base of the penis. And in response to sexual stimulation, they secrete, again, the alkaline mucus fluid that helps flush the urethra, right? Neutralizes any acidic urine, and also helps lubricate the genital. Okay, regulation is much easier for men than it is for women. We will just go through the slides, and you probably will understand. At the start of puberty, the hypothalamus increases its production of GnRH. It's the same hormone in both male and female. And then that will trigger the anterior pituitary to release FSH and LH. So in female, the FSH triggers the development of the follicle. Remember, follicle becomes egg, right? But in men, there's no egg. So instead of oogenesis, it is going to be spermatogenesis. Spermatogenesis. Okay, I got a question from the chat. Does this mean that the thick milky fluid is not sperm? Well, that whole thing that comes out, right? That's the semen, and in the semen it contains the sperm. But the milky stuff, yeah, that's basically mostly the alkaline solution, okay, from the seminal vesicle and from the prostate. But the sperm is in there, okay? Unless the man underwent the vasectomy, then it's just the semen with no sperm, okay? Yeah, so FSH promotes spermatogenesis, and then the LH promotes the testosterone production. Okay? LH promotes progesterone, right, in female, but in male, it is testosterone. When the amount of testosterone in blood rises to a certain level, it causes the hypothalamus anterior pituitary gland to decrease the secretion of GnRH and LH. This is exactly the same thing as what happens in the female. Look, in the female, high, where is it? High progesterone. Look over here. High progesterone is going to shut down GnRH, FSH, and LH, right? So in the same way, again, men, we have the testosterone instead. It does the same thing, right? Through negative feedback inhibition, we're going to bring down the GnRH, LH, and FSH. So this is the map. Okay? In the beginning, we have the hypothalamus secreting the GnRH, triggering the anterior pituitary to release the FSH and the LH. FSH is gonna facilitate spermatogenesis. LH is gonna stimulate, they call it the Leydig cells, but earlier we said the interstitial cells, right? And that's gonna reinforces the spermatogenesis, and then the testosterone will go back and inhibit these things. There is even an extra hormone called inhibin, but don't worry about it. Okay, I mean the name inhibin suggests it inhibits the production, right? So that's that.
Quick question.
Yeah.
So what causes the level of testosterone to go down? Like, is it just like a fluctuation throughout the month, or?
Yeah, it is. Well, not so much the month. Like it's like almost like daily fluctuations. Okay, like if you already have adequate sperm production, then you kind of shut it down a little bit, right? But then as soon as you turn it down, eventually then the production rate is gonna go down, and then you're gonna need to boost the testosterone, right? Do you understand? It's like the thermos, right? The heat doesn't turn on the whole day. It just goes up, but as soon as it turns off, temperature drops. Eventually, you hit a trigger point, and then the heat turns up again, and it's like on and off, up and down fluctuation. Okay, that's it. That's it. All right. So just a couple questions here. Fructose, which secretion is produced by? Which one is it? Does anybody remember? I know I went through it quite quickly, but
Double urethral gland.
no, that's the one that is for the this is the one that flushes the urethra, right? And lubricates the penis. Remember, that's like the thing that comes out first. But for the fructose rich, yes, it is the where is it? The seminal vesicle. Okay, seminal vesicle. It's all in the notes. Okay, how about this one? Cutting the vas deferens will result in
C.
C.
Yeah.
Semen with no sperm. That's right. Yeah, they have other techniques now. I saw something like they could like inject a gel or something that blocks it. They could put a clamp in there. There's lots of stuff they can do. Sounds painful though, if you ask me. So that's it. Okay. Now let's go back to the study guide for a second. Let's fill in these charts before we go. And that's gonna help you understand the stuff better. This is gonna be another like 20 minutes or so. Okay. Okay. Let's see what's going on here. So, GnRH, is it in male or is it in female?
Both.
Both.
Yeah,
Both. Both.
good. Trick question. I just just want to see if you guys are listening. So where is it from though? Where is the GnRH from? Location of secretion. Where?
Pituitary gland,
Higher up, higher up.
hypothalamus.
That's the one. Hypothalamus. Okay. Listen, guys, these charts are gonna be your best friend for the final test. Okay? There's so many hormones, like 20 of them. Okay. So organize these charts. Make sure you have them accessible. It's gonna help you. Okay, stimulus. Well, it's gonna be different for male and female. For female, I'm gonna just use red. Use whatever color you want. For female, it is going to be a drop in progesterone. Remember, the progesterone has a suppression on the GnRH. So if you drop the progesterone level, you lift the suppression, and then you will release GnRH. But there is another trigger in female for GnRH. What is it? Increase in what?
Estrogen?
Yes. Remember, estrogen has positive feedback, right? Positive feedback. They will encourage the hypothalamus to release more GnRH. For men, the trigger is drop in testosterone. There we go. Now, the effects are the same for both men and women. It will trigger the AP to release follicle stimulating hormone and luteinizing hormone. All right, let's move on to follicle stimulating hormone. Where is it from? You can do it. Where is it from?
The pituitary gland, the anterior pituitary gland.
That's right. The bigger bum cheek, right? In our picture, if you remember. Right? The anterior pituitary gland has the FSH and the LH. Okay? Start memorizing some of these things if you can, because there's a lot more. You know what? Let's spell it out. Anterior pituitary. Okay, and the trigger. It's the same for men and women. It is increase in GnRH. If it's the same, I'm just gonna use black. Okay, that's what the color means. For ladies, the FSH is gonna trigger the development of follicle, which is, we call that oogenesis, right? You learned that from me last semester. Do you remember you learned that from me last semester? By the way, like if you wanna bookmark all the videos that we have, because after the course is done, you won't have access to the show anymore, okay? So what I have been hearing back from people who went on to nursing is that they found the notes to still be quite useful. Because you're gonna be learning the same thing, but like in much more detail and much quicker, I was told. Okay, like really fast, right? So bookmark everything and download all the notes before the end of the course. You know, for keepsake, right? What about for men?
Excuse me.
Yes.
Can I download the record?
Yeah, I mean, you can bookmark it. Okay, I'm not gonna
Oh.
like the best way to do it is just to go to the, what do you call that? Like the archive, right? With all the links,
Oh.
just copy all of them and then save it on your computer. Yeah, because I won't be
Okay.
deleting them from YouTube anyways, so that they will be there for a long, long time. Okay.
Thank you.
Yeah. Okay, so development of the follicle, and for men, it is the basically spermatogenesis, right? Stimulate spermatogenesis. There you go. Oh, and you guys might receive like a little email about doing the course evaluation, right? Please take a moment and do that. Okay, so I don't know if you know that, but like every year I have to, because I'm the coordinator, right? So like I have to fill in these reports that talks about how the programs are doing. So when I fill in those reports, I really rely on the comments you guys give us in the courses, both good and bad, okay, so that we can make recommendations to do better and help help the program grow, right? So please take a moment and do the course evaluation if you can. Thank you.
Sorry, I have a question regarding that.
Yes.
So I was gonna do it, but it says like that you guys can like see it.
We
I'm
can
like,
see
Alright.
the results, but we cannot see who does it. Okay.
Okay, so I was like, I don't want to say something that like
No,
I
no,
think
no.
could
It's
be fake.
completely anonymous. So yeah, be honest is really important to be honest. You know, when you guys do those things, there's no way we can track down who said what. Okay. Yeah. Yeah. Um, yeah, I got some fairly nasty stuff in the past. Like I have no idea. Like one semester, not too long ago. Like I think it was just two semester ago. Someone said, he clearly does not care about us." And then I look at it, I was like, hmm, I wonder where that came from, right? I wish the person elaborate a little bit. Anyway, for the record, I do care. Okay, I do care a lot. So luteinizing hormone, where is that from? That is anterior pituitary. Anterior pituitary gland again, right? And again, the trigger is increased GnRH. Increase in GnRH. Okay, let's see what else do we have here. What does it do? Well, LH search is going to trigger. LH search triggers ovulation. And it's gonna create, what does it create? You know, that thing that comes after the ovulation. What do we call that?
The corpus luteum.
Yeah, that's right. Creates the corpus luteum. Okay, which then increase progesterone, right? The key thing is that it triggers ovulation and then it increases progesterone. And for men, what's the analogous hormone for progesterone in men? What do we have instead? Instead of progesterone, we have
Testosterone.
testosterone. They are both sterone. What does that mean? Do you remember from last semester? What is sterone suffix? What does that mean? They are both steroid, okay? Remember steroid, 4 rings. Cholesterol is the starting material that makes the progesterone and the testosterone, right? Okay. Enough reminiscing about last semester. Let's move on. We have the estrogen here. Estrogen, the location secretion is the ovary from the developing follicle. And the trigger is increase in FSH. Effects, increase GnRH, increase more FSH, and LH. These are called positive feedback. Thickens endometrium. If we're talking about puberty, then this will also develop sexual characteristics. I think they're called like secondary sexual characteristics. Okay. For progesterone, it is also from the ovary, but this time it is the corpus luteum. Remember, corpus luteum does not last forever, right? It's just a transient structure that will cause the trigger is increase in LH. Okay, formation of corpus luteum. And it's opposite to estrogen, right? You're gonna have a drop in all these things. which is negative feedback. And then it's the same. Okay, I'm just gonna be lazy and copy it. There we go. Thickens the endometrium further. Also development of secondary sexual characteristics. And last but not least, we have the testosterone, which is produced in the testes, specifically the interstitial cells. Increase in LH once again. And negative feedback. So drop in GnRH. Promote spermatogenesis. Okay. That's all. Any questions? All right. I'm gonna go through some of these application questions because some of them will show up on the test. All right, so let's just go through. They're a little bit long this time. I'll just read it to you. Theon is upset about his low sperm count and decides to buy testosterone supplements online. He took twice the recommended dose. The supplements increased his libido and made him feel more masculine. After taking the supplements for a few months, he went to his doctor to do another sperm count. How do you think the sperm count results will be? Okay, what do you think? Anybody? Just like open discussion here. What do you think? It's going to be more or less, same?
I think more, but I don't know by reason.
Okay. Anyone else? Maybe let's do a poll and see what people think. It's always better when it's anonymous poll. Okay. If you think it's more sperm, then it's A. Okay. Less sperm, then it's B. No change, then it's C. What do you think, huh? Okay. A lot of people say it's more. Well, actually, you know what? It's counterintuitive. You would think it's more, right? Because testosterone, spermatogenesis. But take a look at what we just did. High testosterone will lower GnRH, lower FSH, lower LH. Okay, so if you consistently increase the testosterone level, your body would naturally lower all these things, and that could result in a drop in sperm count, right? Because of the negative feedback. Okay, so that is the reason, okay? Because of the negative feedback primarily. Okay, and as soon as you take it, as soon as you go off the supplement, you know, it's kind of like a caffeine crash, right? Kind of, okay? Like your body's not going to be able to bounce back to the previous level. Okay, here is another one. The I can never say this name, but so I'm not going to try. But that is a synthetic progesterone that is sold under the brand name Plan B. Some of you might have heard of Plan B, right? It's a very common thing. You can just buy it from the pharmacy. You don't need a prescription. It is commonly known as the morning after pill, which prevents pregnancy after unprotected sex. Statistically, an estimated 0.6 to 2.6% of women who take the morning after pill after unprotected sex will still get pregnant. On the product's website, it explains this is not an abortion pill. Based on knowledge of the female reproductive system, explain how the drug cannot prevent pregnancy 100% and why taking the drug will not cause an abortion if you are already pregnant when you take the pill. Okay, so this is synthetic progesterone. Okay. So really, we have to think about what progesterone does. What does it do? If you remember anything at all from today's lesson, from the chart, from the diagram, all the stuff we draw, what does progesterone do to other hormones in the body? Does it increase things, or does it decrease things? Like, what does it do?
After pregnancy?
Not after pregnancy, okay, just like progesterone in general. What does it do?
Increase.
Did you say increase or decrease?
Decrease.
Decrease.
Excuse me, decrease.
Decrease what? Decrease what?
Decrease progesterone. Lead.
Yeah, that's okay. Take a look at the note.
Allow to circle continues.
Okay. Okay. Anyone else? What does progesterone do? What does it decrease? I agree with the decrease. Help me out, guys.
It decreases the GN,
RH. Yeah. And what else does it decrease? Yeah. And
the LH, negative
that's right.
feedback.
That's right. Very good. Through negative feedback, right?
Negative
So the drug, which is essentially functioning as progesterone, will cause these things to happen. And if you have decreased LH, that means no LH surge. No LH surge means no what? If you don't have the LH surge, what event is not going to happen?
Not going to ovulate.
No ovulation. That's right. No ovulation means no egg. Can't get pregnant without an egg, right? So even if there's sperm in the body, the drug will block the egg from being released if it hadn't already been released, right? However, if the egg is already released, then taking the drug is not going to prevent the pregnancy. Okay? If the egg is already there, the drug is not going to like interfere with the egg in any way, right? So that's why there's still a chance for pregnancy. I mean, just because there's an egg and then there's sperm doesn't necessarily mean there will be pregnancy. So, but then, you know, it could, right? It could. So the drug does not does not stop the egg in any way. Okay, it prevents the egg from being released if it hasn't already been released. If it's already released, then there is nothing you can do about it, right? Does that make sense? Any question? No? Okay. There's this thing that is used to induce ovulation in some forms of infertility. Its function is similar to GnRH. Explain how clomiphene can induce ovulation. Well, if its function is similar to GnRH, that means increased GnRH equals to increased LH, right? And increased LH means ovulation. And then it will also increase the chance of twins by about 10%. Of course, because if you increase GnRH, you're going to increase FSH. If there are higher FSH in the body, it might lead to more than one follicle developing at a time, right? So if there are more than one eggs, then there's a higher chance of getting, non-identical twins in this case. In an experiment, rat ovaries were removed immediately after impregnation, like after getting pregnant. And then the rats were divided into two groups. Treatments and results are summarized as follows. Okay, so this is group one. Again, both groups have no ovaries. They removed them. Okay. So in group one, they received daily injection of progesterone of 0.25 milligram. How many rats were able to carry the fetus to birth? 0. Right. And then over here, they give them injection of progesterone of 2 milligrams, and all of them were able to carry the fetuses to birth. So what is the explanation? Well, this experiment shows that progesterone is necessary for maintaining the pregnancy. And we understand why. Because the progesterone will help maintain the endometrium, right? Where all the blood vessels are. If you drop progesterone all of a sudden midway in the pregnancy, that's dangerous. Nothing is maintaining the endometrium might shed. That could lead to miscarriage. Okay. All right, that is all for today. Lots of stuff going on, but not too difficult, I would think. So I'll see you two more times next week for our final lessons. And then that will be it for the course. Okay, feel free to email me if you have any questions. Otherwise, enjoy the rest of your week. Okay, take care, guys. Bye-bye.